morning everyone. Today I am going to take a practical of applied electronics. It is experiment number 13, voltage shunt feedback. So this is the circuit diagram of voltage shunt feedback amplifier. So this is a single stage C amplifier. Here RF resistor is connected from the collector of the transistor here. If you can see, this RF transistor which is connected from the collector of the transistor. Some are giving out, so we are giving output voltage with the help of feedback to the input voltage. So that is why it is called as voltage shunt feedback. So at the collector we are collecting, from here we are collecting the output, and here we are giving the, from here we are giving the input. So here feedback resistor is fed back from the output to the input side. So this RF resistor is of given as 10 kilo ohm resistor used over here. Okay, and from here you will get the input voltage. Now we will go to the directly go to the practical setup of voltage shunt feedback. So this is a voltage shunt feedback practical trainer kit. So here we are giving the inputs signals with the help of function generator. So here frequency, here this is a circuit diagram which I have shown you just now. So from here we are giving the input signals with the help of function generator. Here input frequency is given as 1 kilohertz or 1000 hertz, and voltage amplitude is 20 millivolt. This is the input voltage. From this leads we are getting the outputs on the CRO. Okay, so let's see the observation table. So in this circuit we have one knob. Okay, so in this circuit we have, so this is the observation table. So what we have to do, you have to put input voltage as 20 millivolt, which we have seen in the function generator, and by varying the input frequency we will get the output voltage with feedback and output voltage without feedback, and depending on this output voltage and input voltage I have to calculate the gain. So in this circuit we have a knob, so if you move forward then we will get the output voltage with feedback, and if we move the backward then we will get the output voltage without feedback. So if you can see, output increases without feedback and output decreases with feedback. Your signal gets increases without feedback and decreases with feedback. So depending on these various frequencies we'll check for the output voltage with feedback and without feedback. So let's go to the 10 hertz first. First calculate for 10 hertz. For 10 hertz input frequency, the output voltage we will get as, for without feedback it is 0.02. It's 0.02 into time per division is given as 0.1. So 0.02 into 0.2 into 0.1, that will become 0.02. Let's note down the figure in the observation table. It's 0.02 with feedback and without feedback. Now we'll check for 50 hertz. For 50 hertz we are getting, now it's in with feedback we are getting, it's 0.5 multiplied by 0.1, just time per division, then it will become 0.05 and 0.05 with feedback. Now we'll check for without feedback. For without feedback we are getting without feedback we are getting it's 0.6 I guess. 0.6 multiplied by 0.1, it will become 0.06. Note down on the table, observation table 0.06. Now move to 100 Hz. Let's see for 100 Hz. For 100 Hz without feedback, we are getting it's 0.7 into 0.1, then it will become 0.07. It's 0.07. Now we'll check for with feedback how much will be the result. It's 0.6, then it will become 0.06. Okay. Now we'll check for 500 Hz now. Now we'll check for 500 Hz. Now we'll check for 500 Hz. For 500 Hz, it's just a signal XY. It is 1 point. It is 1.4. That will become 0.14. And for without feedback, it is coming. It is 1.9. So it will become 0.19 without feedback we are getting. Okay. 0.19. Note down on the table. Now we'll check for 1 kilohertz. Now we'll check for 1 kilohertz. For 1 kilohertz, we are getting the output. It is without feedback we are getting 2.4. Then it will become 0.24. 0.24 without feedback. Now we'll check for with feedback how much will be the at 1 kilohertz. It is coming 1.6. That is 0.16. Now we'll check for directly 5 kilohertz. Now we'll check for 5 kilohertz. For 5 kilohertz, it's coming 1.8 with feedback. It is 1.8 multiplied by 0.1, it will become 0.18 with feedback. 0.18, note down on the table. And without feedback, it is, let's see, without feedback it will become 2.8. It is 2.8 multiplied by 0.1, it will become 0.28. It is 2.8. Now we'll check for 10 kilohertz. For 10 kilohertz, without feedback, it is coming 2.6. into 0.1 it will become 0.26 without feedback, and with feedback it is coming 1.6 multiplied by 0.1 becomes 0.16. If you can see, your graph decreases. Now we'll check for 50 kilohertz. For 50 kilohertz, your graph without feedback, with feedback, it's coming 1.2 into 0.1, it will be 0.12. Sorry, it should be in 50 kilohertz table, and without feedback it is coming 1.4, it becomes 0.14. It should be in the 50 kilohertz table. Now we'll check for 100 kilohertz. You see here graph again decreases. For 50 kilohertz it is 1.2 into 0.1, it will become 0.12, and for without feedback it's coming 0.08. Okay, now we'll check for 500 kilohertz. For 500 kilohertz it will be 0.4, it is 0.04, and in case of without feedback it is same, 0.4 into 0.1, it will become 0.04. Okay, so you can see from now we'll check for 1 megahertz. For 1000 kilohertz output will become 0.02, and in case of without feedback it is again 0.02. Okay, so here you can see from 10 hertz to you can say up to 10 kilohertz the graph increases. 10 hertz to 5 kilohertz your graph increases, but after 10 kilohertz your graph decreases. Now you can calculate the gain in dB by using the formula output upon input, V naught upon V in. Okay, 20 log V naught upon V in. So here input voltage is same 20 millivolt, and output voltage is this one, the output voltage. One by one you can calculate for with feedback and without feedback, and the answer will be in terms of dB. I hope you have understood the concept of voltage and feedback. Thank you.